Hi guys, so this is 3.4 solving exponential and logarithmic functions. In my opinion, this is a really fun section because we're using all our properties to actually solve. So I really like this section. So starting with some strategies, if you have an exponential equation, there are two different strategies you can use. First, if you are able to, I recommend you rewrite both sides with the same base, and then you can put the exponents equal to each other. Or you can take the logarithm of both sides after isolating the exponential. So two different ways to do that. Um, the second one, there's more than one variation, but I'll show you a couple. Here we go. 4 to the x equals 32. So I know 4 can be written as 2 squared, and then you're still going to have it raised to the x power equals, and then I know that 32 can be written as 2 to the 5th power. So the goal is you want to get the bases the same so that if the bases are equal, then you can put the exponents equal to each other. So now I can simply put 2x equals 5, and then I can solve for x. So x is equal to 5 halves or 2.5. So I'll just leave it as 5 halves. So that's how you do example number 1. So B, we have 8 raised to the 3x equals 360. There is not a base that I can use to rewrite to get those two bases the same. So what I'm going to do instead is I'm going to take an approach of taking the logarithm of both sides. So if I take the log of the left-hand side, I would also take the log of the right-hand side. And I think I will have to rewrite it instead of trying to squish it in. So I have log 8 raised to the 3x equals log 360. So now that I've taken the log of both sides of the equation, I can use my properties, which means I can take this exponent and use the exponent property where I can bring this down in front as multiplication. So then I have 3x log 8 equals log 360. From there, I remember that I am trying to get the x by itself. So I will divide by log 8. And then this 3 is also being multiplied. And so you can divide both sides by that 3 as well. So the 3's will cancel, the log's 8's will cancel. And now I have x equals. And without a calculator, I'm done. With a calculator, I could just throw in log 360 and 3 log 8, and that's going to be my solution. Now, I do want to point out there would be one more way to do this problem. So just looking at this, if you didn't want to take the log of both sides, you could change the original into logarithmic form to begin with. So to do that, I would do log, and then it would be base 8, and the answer is 360, and that's equal to the exponent of 3x. Okay, from there, I could just divide both sides by 3. And the reason why this method is useful is because on the calculator now, I can go to green alpha F2, and I can put in log 8 of 360 divided by 3. So log 8 of 360 divided by 3, and that's going to tell me what x is. So without a calculator, these are my answers. Both of these are equivalent. Okay, so let's look at C. So looking at C, what we're going to do is we're going to start by isolating the exponential. So I want to isolate the e to the x. So when you go to isolate, here's the e to the x. You want to undo the add subtract first. So you can start by subtracting 7. This gives me negative 2e to the x equals negative 2. Then you can divide by negative 2. A negative divided by negative is a positive. So e to the x is equal to positive 1. And then I know what x is because e to the 0 would equal 1. So therefore, x is equal to 0. All right, and there's my solution. So now we're going to do some strategies for solving a logarithmic equation. So you can condense any equation using the properties of logarithms, rewrite the equation in exponential form, and then it's really important that you always check for extraneous solutions because sometimes you'll get answers that are undefined. All right, so starting with example 2, we have ln x subtract ln 5 is equal to 0. We want to start this problem by using the property of exponents, which is condense. So when we condense, we have 1 ln. Where the subtraction is where the division sign goes. In front is the numerator, which is x, and below would be 5. So this gives me ln of x divided by 5 is equal to 0. Now from there, the second step we're going to do, so the first step was to condense. The second step is we're going to rewrite it in exponential form. So again, if it's ln, we know that the base is e. So let's recall that you go the base, ln is a logarithm, so it's always equal to the exponent. So 0 is the exponent, and I'm going to refer to x over 5 as the answer. So now we're ready to go. We're going to rewrite that in exponential form. We have e raised to the 0 is equal to x divided by 5. From there, I know e to the 0 is 1. So 1 is equal to x divided by 5. And then we would multiply both sides by 5 in order to solve for x. So x equals 5. Now we want to check to make sure that this is a solution. So let's look at the original and let's plug in x. So looking at the original, I have ln 5, and this makes perfect sense that it's going to work. ln 5 subtract ln 5 is going to equal 0. Check, that works. So this one, there's more than one way to do the problem. I actually like doing it this way that they give us in the note, which is we're going to take x to the 4th equals 625. So let me show you. Log base x of 625 equals 4. I'm going to change it to exponential form. So the base is x. The power is 4 because a logarithm is always equal to an exponent. So there's your exponent, there's your base, here's your answer. So x to the 4th is equal to 625. All right, and then how do you get rid of raised to the 4th power? You can take both sides to the 1/4 power. This is like the problem we did in class. Or you can take the 4th root, which is the same thing. So once I do that, I get x equals, and then simply take the 4th root of 625, and that's going to be your solution. So here's the second way to work out that problem. If you have log base x of 625 equals 4. So it says rewrite in exponential form. So the base is x. Here's the base. The exponent is 4. Logarithm always equals the exponent. And the answer is 625. Now what you can do is you can actually take the log of both sides. Because it's an equation, you take the log of each side. Now you can use the property of logarithms where you can take this 4 and bring it out in front. So this is 4 log x equals log 625. We would divide by 4. So now I have log x equals log 625 over 4. Now, I would have to change this back to exponential again. So the base is base 10. So this would be 10 raised to the log base 10 of 625 over 4 is what equals x. You can see I'd still have to throw that into the calculator. It was much harder than this one, so I would do it this first way. Looking at C, we're going to condense. So you have log base 3 of x and log base 3 of x minus 8. When you condense that, you have 1 log base 3. Oh, I don't want red. I want purple. So you have 1 log base 3. And then because of this addition, you're going to have x times x subtract 8 equals 2. Now we're going to change it from logarithmic form to exponential. So the base is 3. The exponent is 2. And the answer is x squared subtract 8x. And I just distributed. All right, from there we have a quadratic equation. So the quadratic equation is x squared subtract 8x equal, let's go ahead and subtract that 9 over. Subtract 9 is equal to 0. And you would factor this. So you have x times x is x squared. And 9 times 1 is 9. And we want this to be negative and the 1 to be positive. So x is going to equal positive 9 and x is going to equal negative 1. Now, here's the deal is we have to have, remember, you can't take the log of a negative number. So when we look up at this original equation, where x is right here, this area here has to be positive. So let's go ahead and check both of these and see which one works. Maybe both will work. Let's look. So this is log base 3 of 9 plus log base 3 of 9 subtract 8, which is equal to 2. Now log base 3 of 9 is 3 to what power is 9? And that's going to be 2. So 3 to the second power is 9. Plus 3 to what power gives you a 1? That would be 0. And 2 plus 1 equals 2. Check. So 9 is definitely a solution. Now let's try negative 1. Well, negative 1 is not a solution because if we take log base 3 and then in place of x we put in a negative 1, then what I'm asking you is I'm saying 3 to what power gives me an answer of negative 1, and that's impossible. So this answer here always has to be positive, and it's not. And so that one is extraneous, and my only answer is x equals 9. If you were in class, I wouldn't just work these all out for you. I would actually have you try these on your own. So I would really recommend following the instructions, try it on your own, and then you could just fast forward the video and see if you got the answer right. Rewrite in exponential form. So the base is 5. The exponent is 1, and it equals 4 subtract x. Now we're going to solve for x. I don't love that I'm in red, but in the interest of my time, I think I'm just going to leave it. So I will subtract 4. So 1 equals negative x. And then if you divide by a negative 1, then you have x equals negative 1. Okay, so we're wondering if this is going to work or not. So just because the answer here is negative doesn't mean it's going to cause this part here to be negative. So we want to just go ahead and plug it in. So we have log base 5 of 4 subtract, and then I'll plug in the negative 1 equals 1. Well, this is plus plus. So even though this came out as x is negative 1, I'm not finding the logarithm of a negative. I'm finding the logarithm of 5. So log base 5 of 5 is equal to 1. Well, this is true, check. because, why is it true? Because the base of 5 raised to the first power equals this right here is your answer of 5. Check. This says solve the equation log x squared equals 6. You rewrite using the properties of logarithms. So we'll bring the 2 in front. And then I have log x equals 6. I can divide by 2. So I have log x is equal to 3. Now, even though I don't see a base, the base is base 10. I'm ready to change to exponential form. So the base is 10. Log is always equal to the exponent, so that's 3. And it equals x. Therefore, x is equal to 1,000. So there is my final answer. Good to go. So I should show you how it checked as well, since it says check. So if you have log and you do 1,000 squared equals 6, check, that works. There you go. So example 5 is kind of a challenge problem. I recommend you giving it a try on your own. If you want a hint, here's a hint for you. So we're going to let 2 raised to the x equal u. This is kind of quadratic in nature. So this is 2 raised to the x times 2 minus 6 times 2 raised to the x minus 7 equals 0. This first one, I just changed the order. So now what I'm going to do is everywhere I see a 2 raised to the x, I'm going to replace it with u. So this is going to work out pretty cool. So this is going to be u squared subtract 6u subtract 7 equals 0. So u times u, excuse me, is u squared, and 7 times 1 is 7, and we want this to be negative and this to be positive. So u is equal to 7, and u is equal to negative 1. So now we're not quite done yet. We need to come up to the problem, and we need to take 7 and negative 1 and plug those back in. So let's do that now. So since 2 to the x equals u, you would say 2 to the x is equal to 7. And the other answer was negative 1. So you would say 2 to the x equals negative 1. So from there, I don't know 2 to what power is 7. I have no idea. And so we're going to go ahead and change that to a logarithm. So this would be the log of base 2 of an answer 7 is equal to x. Then you could take your calculator and you could just plug that in. Here would be log, the base is 2, the answer is negative 1, and it equals x. Now we know off the bat that this, the answer right here cannot be negative, because 2 to what power gives me a negative 1 is absolutely impossible. So this one is no good. So this answer here is no good. But log base 2 of 7 is an answer, so that will be my answer. You could leave it like that. If you wanted to, you could use change of base, log 7 over log 2. Or you could throw it into your calculator for decimal. I prefer this right here. It's good. Thanks. So I'm hoping you're finding these super fun like I am. I think they're really fun. Here we have an issue because I cannot get these bases to be the same. It's impossible. So there's more than one strategy for these actually, but we're gonna take the strategy of taking the log of both sides. So basically you're gonna take the log of both sides, and then you can take the exponents and bring them out in front. So this would be 3x log 4. I know I was a little bit lazy and didn't want to rewrite it. And then x minus 1 would come out in front, and you would have log 7. All right, so from there, let's keep in mind that we're trying to solve for x. We're going to take this log 7 and distribute it. So this is just some algebra. So I have 3x log 4 is equal to, I have a log 7 times x, which would be log 7x. And I have a log 7 times -1, which is negative log 7. Now, you want to gather all your x's. Here's an x and here's an x. You want to gather all those x's together on one side. So I will just go ahead and take this log 7x and subtract it over to the left. So now I have 3x log 4 subtract log 7x is equal to negative log 7. You want to think about it for a minute. You can stop the video. What are we going to do? We are going to factor out the x. So we factor out the x, leaving me 3 log 4 subtract log 7, which equals negative log 7. Now to get x by itself, all I do is divide this long, messy part, which is no problem. In the end, you could use a calculator. So 3 log 4 subtract log 7. Those cancel. So I would recommend just leaving it just like this. If you used your calculator, use the green alpha F2 button with the fraction bar. If you don't use a fraction bar, you'd have to use parentheses around the denominator, or it's going to give you an incorrect answer. You are supposed to check this. So how you would check it is you would come up to the original, plug this messy old thing in for x, and see if both sides are equal. It is a little bit of a large attempt to check, and in the end, it does check out. Put this in your calculator for practice and see what you get. The approximation is negative 0.879. So that's the answer you're going to get once you plug it into the calculator. This is a you try, which means you're going to try it on your own. And we'll hit it in class as well. But I would like you to remember the formula. Population in terms of time is equal to A, which is your initial value, times B, which is your rate it's dividing. If it's dividing every hour, that's a doubling rate, raised to your time. So give A and B a try. And then also don't forget to do your reflection. Thanks, everyone.